Today what I want to do is go over some additional problems in chemistry. So the last time we met is we were talking about how to take grams of a substance into moles of a substance, then moles of a substance into molecules of a substance, and you can go back the other way. Now sometimes in the problem you will have, for example, a molecule of a substance, and you'll have to, like in the middle of the problem, convert that into atoms of a substance. So I sort of need to show you how to do that. So that's what I'm going to talk about today. So one way to think about this is through a simple example. So as you know, if you have one molecule of AlCl3, which is aluminum chloride, you know that in that one molecule of AlCl3, you have one atom of aluminum and 3 atoms of chlorine. Now, because that is the truth, what you can also say is that 1 mole of AlCl3 contains 1 mole of aluminum and 3 moles of chlorine. Based on that, what you can do is set up a few equalities and then some fractions that can help you solve the problem. So at this point, what I want to do is kind of go to the board and kind of write this out to some degree to explain how we can get to some of these useful fractions. So you can say again, 1 molecule of AlCl3 contains 1 atom of aluminum and 3 atoms of chlorine. So we can take this and write 1 mole of aluminum chloride contains 1 mole of aluminum and 3 moles of chlorine. So at this point what we can do is we can set up some equalities. So let me give you some examples, some equalities we can set up. So one equality we can set up is that 1 mole of AlCl3 is equal to 1 mole of aluminum. So let's write out some fractions you can write from this. So you could put the numerator, the left number here in the numerator and the right number in the denominator. So you could write 1 mole of aluminum chloride over 1 mole aluminum, and you can write the reverse, 1 mole of aluminum over 1 mole of aluminum chloride. Now, this is not the only equality that is mentioned sort of in these word equations here. What you can also say is that 1 mole of aluminum chloride is equal to 3 moles of chlorine. So I'm hoping you know at this point you can set up 2 fractions from this. I'm just going to write out 1. So maybe I'll write 3 moles of chlorine over 1 mole of aluminum chloride. And you can just write the reverse fraction. Now there's one more fraction you can write. So in this particular problem, when you're dealing with this molecule, what you can see is that for every 1 mole of aluminum, you will have 3 moles of chlorine. So that is an equality in itself. So we can write 1 mole of aluminum is equal to 3 moles of chlorine. And so we can write, as an example of a fraction, 1 mole of aluminum over 3 mole of chlorine. And again, you can write this in reverse. So there are a number of fractions that will allow you in the middle of a problem to convert, say, moles of a compound to atoms of a compound or vice versa. And sometimes that's needed in a problem. And we're going to go into that right now. So what I wrote down here, I've got on the screen right there. So let's go directly to some problems. So the first problem is, how many moles of atoms of each element are there in 0.25 moles of aluminum sulfate? So we have 0.25 mole of aluminum sulfate. Okay, so what we want to do is find how many atoms there are, or rather how many moles of each of the different elements there are in this compound. So we're going to first find moles of aluminum, and then we're going to find moles of sulfur, and then we'll find moles of oxygen. So let me show you how that's done. So what I'm kind of hoping you see at this point is you can see that 1 molecule of aluminum sulfate contains 2 atoms of aluminum. So we can say 1 mole of aluminum sulfate contains 2 moles of aluminum. So what we can do is put in the appropriate fraction so that moles of aluminum sulfate cancel out, leaving the answer in moles of aluminum. So it would be something like this. Okay, so what you would hopefully see is that the moles of aluminum sulfate cancel out. And so what is your answer? Well, your answer is going to be 0.25 moles of aluminum sulfate times 2 moles of aluminum divided by 1 mole of aluminum sulfate. So you're going to be left with an answer in moles of aluminum. So the math is just 0.25 times 2 divided by 1. So we should get as an answer 0.50 moles of aluminum. Okay, so let's try taking this aluminum sulfate now to moles sulfur. So again, we have 0.25 moles of aluminum sulfate. And here we're going to get it to moles sulfur. And so we sort of have to figure out how many moles sulfur there are in this compound. So it looks like for every 1 molecule of aluminum sulfate, we have 3 atoms of sulfur. So if we have 1 mole of aluminum sulfate, we should have 3 moles of sulfur. So I'm going to write here 3 moles of sulfur over 1 mole of aluminum sulfate. And so moles of aluminum sulfate cancel out. So you should get an answer in moles sulfur. And so it should be 0.25 times 3. So that should be 0.25 times 3 is 0.75 moles of sulfur. Okay, so let's try moles oxygen. So moles oxygen, this is a little distracting here. I'll do this as well. So it's going to be 0.25 moles of aluminum sulfate. And here we want to get to the moles oxygen. So you have to figure out now how many atoms of oxygen is there in 1 molecule of aluminum sulfate. And so what you should see is there's 4 oxygens times 3. There are 12 oxygen atoms per molecule of aluminum sulfate. That means there are going to be 12 moles of oxygen atoms per 1 mole of aluminum sulfate. So it's going to be times 12 moles of oxygen atoms over 1 mole of aluminum sulfate. And so the moles of aluminum sulfate cancel out. So I probably should multiply this because I'm not sure if I can do this in my head. 0.25 times 12. Ah, yes, it is 3 moles of oxygen. I guess it's with 2 significant figures as well. There's 2 here and there's 2 here. So 3.0 moles of oxygen. So these should be the answers of the moles of the individual elements found in 0.25 moles of aluminum sulfate. Okay, so let's move on to the next problem. Okay, the next problem says how many chlorine atoms are present in 25.1 grams of aluminum chloride? And then we have a formula mass for aluminum chloride. Okay, so we're starting out with 25.1 grams of aluminum chloride. And I think it looks like what we want an answer is we want to figure out, I'll put it down here, how many chlorine atoms are present. So you can see we sort of have a problem here. One problem is we have to convert grams to atoms, but maybe a bigger problem is we have to convert at some point the molecule aluminum chloride to chlorine atoms. And so there, some of the mole proportionalities that I just mentioned might be useful. So the first thing I would do is I would get the grams of aluminum chloride into moles of aluminum chloride. So it's times 1 mole aluminum chloride over the formula mass, which is 133.34 grams of aluminum chloride. So the formula mass is 133.34. That indicates that there will be 133.34 grams of aluminum chloride in 1 mole of aluminum chloride. So at this point, the grams of aluminum chloride cancel out. Now we're left with an answer in moles of aluminum chloride. Now at this point, what I would consider doing is I would convert the moles of aluminum chloride to moles of aluminum using an appropriate fraction. So what you can see just looking at the formula is that for every 1 molecule of aluminum chloride you have 3 chlorine atoms. That means for every 1 mole of aluminum chloride you should have 3 moles of chlorine atoms. So it's going to be times 3 mole of chlorine over 1 mole of aluminum chloride. So where are we at now? So the moles of aluminum chloride cancel out. So now we have an answer in moles chlorine. So maybe the final step here is to take moles chlorine and get that into atoms chlorine. And so there you use Avogadro's number because you know that for 1 mole of atoms is equal to 6.022 times 10 to the 23 atoms. So what we can do is write 6.022 times 10 to the 23 atoms chlorine over 1 mole of chlorine. And so you can see that the moles of chlorine will cancel. And so we should be left with an answer in atoms chlorine. So the math would be 25.1 times 1 times 3 times 6.022 times 10 to the 23 divided by 133.34 divided by 1 divided by 1. So you can work that out in your calculator and it should work out to what is suggested there. It should be 3.40 times 10 to the 23 chlorine atoms. And I'm kind of hoping you can sort of see why this is in 3 significant figures. So we'll move on to the next problem. Okay. If there are 4.7 times 10 to the 25 atoms of phosphorus in a sample of potassium phosphate, and we have a molar mass for that compound, then how many grams of potassium phosphate did we start with? Okay. So here we're starting out with 4.7 times 10 to the 25 phosphorus atoms. And now we're getting, in the end, we want to get grams of it looks like the compound that this phosphorus atoms are in, which is potassium phosphate. So let me work out the formula for potassium phosphate right now. So potassium has a charge of a single plus. Its symbol is K. Phosphate is PO4 minus. And so I think what you can see is that to balance the total charge in this ionic compound, we need 3 potassiums for every phosphate. And so the formula should be K3PO4. Okay, so how do we do this problem? So we have a number of atoms of phosphorus. Let me include atoms phosphorus here. Okay, so the first thing I would probably do is just get this into moles. And then once you have moles phosphorus, then you can convert to moles of the compound, potassium phosphate. And then from there, convert to grams potassium phosphate. And I think that would get us to the answer. So the first thing, let's convert these atoms phosphorus to moles phosphorus. So it's times 1 mole of phosphorus over 6.022 times 10 to the 23 atoms of phosphorus. And at this point, I think you can see atoms of phosphorus cancel. You're now at moles phosphorus. And now let's figure out a proportion so we can convert moles of phosphorus into moles of potassium phosphate. And so I think what you can see by looking at the formula, for every 1 molecule of potassium phosphate we only have 1 atom of phosphorus. So it looks like for every mole of phosphorus we have a mole of potassium phosphate. So what I would write here is times 1 mole K3PO4 potassium phosphate over 1 mole of phosphorus. And let's see where we're at now. So the moles of phosphorus cancels out. So right now we're at moles of potassium phosphate. And so now what we want to do is get moles of potassium phosphate into grams of potassium phosphate. And so what we want to do is multiply probably by the molar mass of potassium phosphate, which is given it to us, which is 212.27 grams of potassium phosphate over 1 mole of potassium phosphate. So you can see the moles of potassium phosphate cancels, and we should get an answer in grams potassium phosphate. So let me do the math. So it looks like to me we're going to have to take 4.7 times 10 to the 25 times 1 times 212.27 divided by 6.022 times 10 to the 23 divided by 1 divided by 1. So let me kind of work that out really quickly. And I get, on my calculator, 16567.071 grams of potassium phosphate. So let's figure out how many significant figures this should be. And it looks like we're going to be limited to 2 significant figures because some of the information in the problem only has 2 significant figures. So let me convert this into 2 significant figures. So it's going to be, let's see, it's going to be 17,000 grams of potassium phosphate, but I would just put this into scientific notation. So it'd be 1.7 times 10 to the 4 grams of potassium phosphate, and that should be your answer. So let's go on to the final problem. Okay, so if we have 100 grams of carbon, it is converted to methane gas, and the formula for methane gas is CH4, and the molar mass is 16.04. How many grams of methane would be formed? Okay, so we have 100 grams of carbon. Okay, so it looks like we have 4 significant figures, so let me correct that really quickly. 100.0 grams of carbon. And so now what we want to do is get into grams of methane, which is CH4. Okay, so what I would do is I would get grams of carbon into moles of carbon and then convert moles of carbon to moles of methane, which is CH4, and then moles of methane to grams of methane. That's the approach I would take. So we have 100.0 grams of carbon, and so what we want to do is get this into moles of carbon, which shouldn't be too bad. So 1 mole of carbon over the molar mass of carbon, which is 12.01 grams per mole. And so you can see that at this point the grams of carbon cancel, you're left with an answer of moles carbon. And so now what we need to do is ask ourselves this question. If you have a molecule of CH4, which is methane, how many atoms of carbon do you have per molecule of methane? And it looks like if you have 1 molecule of CH4, you have 1 atom of carbon, which predicts if you have 1 mole of carbon, you should have 1 mole of CH4. So we can put up that conversion here. 1 mole CH4 over 1 mole of carbon. So moles, carbons cancel, and you have an answer in moles CH4. And then you have to get moles of CH4 into grams of CH4, which shouldn't be too difficult. It's going to be times 16.04 grams of CH4 over 1 mole of CH4. Okay, so the moles CH4 cancel, get an answer in grams CH4. Okay, so the math should be 100 times 1 times 1 times 16.04 divided by 12.01 divided by 1 divided by 1. So it's going to be 100, and the number I get on my calculator is 133.555. Okay, so you would have to round this to the appropriate number of significant figures. We have 4 figures here, 4 figures here, 4 figures here. All the other numbers should be exact numbers with an infinite number of significant figures, so we round this into 4 figures. So it should be 133.6 grams, or we probably want to convert this to scientific notation, so it should be 1.336 times 10 to the 2 grams of methane. Okay, thank you for listening. We will see you next time.